Hey everybody, and welcome to Chapter 2. We are talking about an introduction to research methods, which, you would hope we would cover, given that this is Research Methods 1. But the thing about this is that it is an introduction to everything we're going to be talking about this semester. So if you look at the agenda, if you look at the outline for what we're talking about this chapter, hypotheses and theories, descriptive methods, predictive methods, explanatory methods, different variables used in scientific research. These are all things, these are ideas that don't go away. These are ideas that are going to be staying with us through the entire semester. We will be going through them maybe a little fast and maybe a little, for lack of a better word, at kind of a shallow level. And the reason for that is just because we're going to be covering them in much more detail later in the semester. So, this is all just to say that, we're just going to be kind of giving you a summary of what's to come throughout the rest of the semester. That's different from Chapter 1, where Chapter 1 kind of talked about how we acquire knowledge and why certain sources of knowledge are more reliable and more valid than others. Now we're going to be looking at, well, what happens if we're looking at research and the different varieties of research? How does it start? Where does it end? What does it look like? And things like that. The video that I have to start us out for now, I guess now would be a good time to watch this. If you're following along in your lecture notes, we're just starting this video, but I don't think it would be a bad idea to check this video out. This video is from a YouTube channel called Veritasium, I believe, and they do a lot of, man, my handwriting is so bad. They do a lot of educational, scientific kind of programming for content. Programming. I sound like an old ad executive. But a lot of content. It's really, really great. I'm very picky when it comes to like internet sources and stuff like that. Like, I'm just kind of picky, and I turn my nose up at a lot of that stuff like TED Talks and stuff like that online. But Veritasium is great, and I highly recommend them. But the reason why I'm recommending this specific video is because he is going to show you kind of a bias that most people have when they're trying to uncover information. You're going to see in this video that the host has a piece of information. He wants his audience to figure out what that information is, and the way they're able to do that is through testing. Through testing a series of numbers, and you're going to see that all of them kind of do it badly at first. And so it's a great example of why and how we should approach research questions whenever we are thinking about research, whether we're doing that research ourselves or whether we're reading and consuming research or scientific articles for our own pleasure and information and education, why sometimes we have a bias to do the wrong thing instead of the right thing. Alright, so where we left off last class, we were talking about the different goals of science. We were talking about 3 separate goals. We were talking about describing behavior, explaining behavior, and predicting behavior. And if you back up, you can even see that we have methods for each of these different kinds of goals in psychology. So we'll be talking about what each of these are. So just as a recap, describing behavior is whenever we talk about kind of the topology of that behavior. If I can throw a big word at you, topology basically just meaning what does this behavior look like? When does it occur? Where does it occur? Under what circumstances does it occur? So describing the different facets and characteristics of a behavior. Second, we have explanation. So talking about why that behavior exists, where it came from. And predicting, which is understanding when a behavior will or will not occur. As you can imagine, that can be super valuable. If you plan on going into counseling or clinical work as a psychologist, or if you are wanting to do social work or anything like that, you're going to have to encounter all 3 of these things in your clinical work. So it's important to be thinking about this stuff as a researcher, because you will be using it absolutely as a counselor, clinical psychologist, addict supervisor, what other, I'm trying to think of other kind of popular areas that my students are interested in. So we went over this, so let's get into our circle of science. So here, and you've probably seen some variation of these ideas because at least for me, I feel like I first learned about the scientific method when 4th grade maybe, so chances are you've heard about this stuff too, but I love this figure. It's not the figure that I remember seeing in high school or even in 4th grade, but it does a really great job of showing kind of the flow of events. And we're going to be talking about some of these steps in a lot of detail in this video. So the first that we have here is the theory that leads to a research question, which leads to a research design, which leads to a hypothesis, which leads to your data. When you get to your data, then you have two choices. If your data confirm what you predicted, then awesome. That goes back over to the theory, and you can continue to refine your theory so that your theory is as strong as possible and as comprehensive as possible. If your data do not support your theory, then you kind of go back into one of two different avenues. You can go back to the drawing board for your research design or for your theory. If your data if your data don't support your prediction, that means that either your theory was off, no big deal, it happens all the time, or it means that your research design was off. Again, no big deal, happens all the time. So the reason why I mention that is because a lot of students, whenever they get to this point with their data, if they find that it doesn't support what they suspected, they get really bummed out because it feels like they have to start back at the drawing board. But there's a lot of value that comes in finding non-supporting data, which we'll be talking about later this semester. So what the heck is a theory? A theory is essentially your kind of explanation for why people behave the way that they do. So you can think of the theory as the explanation for the prediction that you have. So we're starting here with theory because theories kind of are going to help us kind of pick a research question and a prediction. Yeah, so a theory. If I can give you an example, let's say that I'm going to use this example a lot because it's one that I have on the mind, which is about social media and being introverted or extroverted. The reason why I have this on the mind is because I had a Research Methods 2 group that was studying a very similar question recently, and basically they found a lot of other research that showed that people who are extroverted, so people who enjoy going out, who enjoy making new friends, who don't like to spend a whole lot of time at the house, they prefer to kind of go out to the club or to the bar or go hang out with friends or whatever, or meet new people. That people who are extroverted tend to spend more time on social media than people who are introverted. That's kind of interesting because some people thought it might be the opposite, right? That people who are introverted are going to spend more time on social media because they don't like to do that stuff out in the real world. But the opposite is true. So the question then is, why? Why do you think that that's the case? And you can come up with your own theory for why you think that's the case. For me, let's say that my theory for that is, I think that extroverts use social media more because, and the key word here is because that's going to explain why that's happening, which makes it the theory, that extroverts use social media because social media is just another tool, like any others, that allow them to meet people. So it's just kind of like extroverts are going to continue being extroverts using this platform, the same way that you would expect extroverts to be extroverts if they went to a club. So that's my theory. Now, from there, I can then devise a hypothesis that can test that theory out. We'll get to that in a second. So, one important kind of piece of semantics, and this is, I'm throwing some high-level stuff at you. This is one of those kind of philosophical points that may not come to you immediately, but will pay off, especially whenever you get to do your own research a couple of semesters from now, or when you start analyzing data next semester when you take stats. So, a theory can't be 100% correct. There's always room for a theory to be improved. But it can be 100% incorrect. I believe that is something that I talked about in the last video about the theory of gravity, about how Isaac Newton thought that the theory of gravity was perfect, right? Well, actually, I don't know. I haven't read his journals or his diary. I don't know if he thought it was perfect, but at least we, humans, civilization for a long time thought that it was, with, the idea of gravity being that things fall towards the center of a large mass. The mass here being the Earth. That was widely held as being absolutely true 100% of the time, the law of gravity. But in the early 1900s, whenever this old guy named Albert Einstein came around with his theory of general relativity, we realized that, hey, maybe gravity doesn't work the way that we thought that it does. Maybe gravity works a little bit different. And so the reason why I bring this up is because that theory about gravity from Newton's times, from Isaac Newton's times, wasn't 100% correct. There was room for improvement. When we start looking at things at a cosmic level, or things at a very small molecular level, the rules of gravity kind of become a little confusing. A lot of things that we didn't know about at the time. So that's just a long roundabout way of saying that a theory can't be 100% correct. There's always room for improvement. But they can be 100% incorrect. A theory can be wrong, but a theory can't be 100% true, because there's always going to be things that we don't know about that. And that's just kind of how science works. As science goes on, we're going to discover more and more and more and more and more things, but we're always going to be a little bit skeptical about it and say there's always room for us to know more about that subject. Alright, one example of this is Freud's dream theory. And I know we talked about this last video, with Freud's dream theory essentially being that, that our unconscious mind is expressing itself, and that is why we dream. So this theory explains a behavior. But this is not a good theory, because it is not falsifiable. You may remember that from the last video. So what the heck is a hypothesis? A hypothesis, I like to think of it as a test. It is a test that is going to determine whether or not your theory is valid or invalid, whether or not it is supported or not supported. So a hypothesis is going to be a testable statement. So it's going to be something that tests the theory that you have observed, the theory that you have noticed about behavior. I think it's always best to frame a hypothesis in an if-then statement. In other words, if something occurs, then something else occurs. So, if I am tired, then I become stressed. In this case, I have a hypothesis, because this is a testable question. It is something that I can test, I can do research on it, I can do an experiment to determine whether or not this is true. How? I can test this part right here. If I am tired, then I become stressed. Okay, so I can devise a study where I know that I become tired, and then I can measure what happens to my attitude. Maybe I become stressed, maybe I don't become stressed. If I don't become stressed, then that means that I can reject this hypothesis. If I find that I am tired and I don't become stressed, I can say this is not... that I reject the hypothesis. I need to go back to my theory to figure out why that was not true. But maybe I test this out, I become tired, and then I notice that I am stressed. Then that doesn't necessarily mean that my theory is true. It just means that I need to further refine that theory. So in this case, maybe I would say that my explanation for this would be, if I am tired, then I become stressed because cortisol levels control stress in human behavior. Cortisol being a hormone that people have observed changes and fluctuates throughout the course of the day. So, let's say that I test this out, this statement, and I find that this statement is true. I can't then say that it's because of cortisol, right? I can say that this supports the notion that it is related to cortisol, and I guess I can write that down on this slide instead of making wild hand gestures. But I should be skeptical, because just because this was right doesn't mean that my theory was necessarily right, but it does mean that it looks like this theory about cortisol may be true, and so I can continue refining this. I can test this at varying times of the day. I can test this out with different levels of tiredness. I can do this with different measures of stress, and so on and so forth. So there's lots of room to kind of study this. So here's the hypothesis statement: if blank, then blank, and here the because, that is going to be our theory. So if you're putting this into words, you would say, if something happens, then something happens because of whatever your explanation is. That explanation is your theory. The reason why I'm breaking it down in this very cookie cutter formulaic way is because this is one of the things that students always kind of have trouble with. Not necessarily in Research Methods 1, but definitely in Research Methods 2. So it can be helpful to be thinking already now about this idea, that your hypothesis should be kind of an extension of your theory. It tests your theory. So if you wanted to try to create new hypotheses, this is again something that students have a lot of time struggling with, is like, how can you develop a hypothesis? Here's a couple of them. Your book also has some examples. I'm just giving you these 4. These come from a paper that I love that was published a long time ago in the 90s that I posted in Plato. You can find it in this folder. You do not need to read it for this exam or for this class even, but I wanted you to have it just in case you were curious. There's like 20 something I think ways you can generate a hypothesis, and here are the first 4. The first being, you recognize something weird about behavior. So you recognize an odd behavior, or you try to explain an odd behavior. By doing that, you might think, okay, well, that's something that I can test. Let's see, something weird about behavior. Yawning, for example, right? Like, yawning is weird. If I yawn and somebody else sees me yawn, then it'll be contagious and they'll want to yawn too. So that is odd. Why does that happen? That might be something that you can fashion a hypothesis of, right? If I yawn, then if someone watches me, they will yawn too, right? That is a testable statement. The next one is introspective self-analysis. So this would be like imagining yourself in a specific situation and then trying to predict what you would do. So in terms of developing a hypothesis for this, you could say like, I feel like if I had to stay in bed for 48 hours straight, that I would develop insomnia. Right? That is an example of introspective self-analysis, where I'm imagining what would happen to me, and I would be predicting what would happen to me, and that is something that I can test. The next one is retrospective comparison. So this would be like thinking about things that you have been through and then trying to extrapolate, or to put another word, to generalize to similar problems that have already been understood. So let's say that we know that yawning is contagious, right? Is yawning contagious with other species? If I yawn and my dog sees it, will my dog yawn? If my dog yawns and I see it, will I yawn? That is something that is testable. That is a hypothesis. And if you want to test that, I'm sorry to say that somebody already has done it. Very interesting stuff here, that basically yawns are contagious. Whenever a dog does it and a human sees it, a human will yawn. But if a dog sees a human yawn, a dog will not yawn. There's really interesting data about that. And if you want to know why that is, we can talk about it over email or something. And then finally, that we have here is sustained deliberate observation. So this would be like if you spend a lot of time working with, let's say that you spend a lot of time around your nephew and you realize that your nephew is doing something kind of strange, which kind of feeds back into step 1 over here, or I should say kind of it's not really a step, but kind of method 1 here. So if you have spent a lot of time around a specific person or organization, you might notice certain things about it and you would want to understand them using hypotheses. Alright, so 5 good things to remember about hypotheses and theories is that a good working hypothesis should follow these 5 things. It should be testable, so it should be falsifiable. We talked about that in Chapter 1. It is not a moral or ethical question. So, as scientists, we're not here to judge anybody. We're not here to try to prescribe morality or ethics to anybody. We're just going to be reporting the data and yeah, that's it. So, for example, this is a real example. I'm going to give you a real example. I hesitated because I feel like I'm worried because we've already spent 20 minutes here, and I want to get you out of here before an hour is over. Just like if you were taking this class in person. So here's a real example of this in practice. I remember one time I was at a conference, this guy was studying police lineups, and he was studying which method of police lineups is better. Is it better to do a police lineup whenever you have 5 people all kind of lined shoulder to shoulder, and then you have the witness kind of looking at these 5 people and then selecting who they think they remember seeing as a witness? That's one way to do it. That's the way you see it in TV shows usually. There's another way of doing it, which is that you have pictures of 5 people and you present it to the witness serially. So you give them one at a time, and then they choose from that. They choose from that series of pictures who it is. So those are 2 separate different ways of doing a police lineup, and they actually have different accuracy levels. One of them is much more likely to have a false positive, where someone misidentifies somebody, so basically falsely accusing somebody, and the other one does not have that, but it's less accurate. In other words, you have fewer false accusations, but you also have fewer correct accusations. So then the question that came up in the audience when this guy finished presenting this data, because it was really interesting, a lot of people were saying like, but wait a second, shouldn't you say that this other method is best because it has fewer false accusations? And I remember a lot of people in the audience agreed with this and were like, yeah, that's right, we don't want false accusations. And I remember that researcher was like, you know what, I understand you, but it's not my job to make policy decisions. It's not my job to put value on either of these methods in that way. It's up to the criminal justice system and legislators and policymakers to do that. So this is just a very long way to say that sometimes the things that you're going to be studying might have moral or ethical outcomes, but it is not necessarily your job as a scientist to kind of say what is the correct thing to do or what is the ethical thing to do. You're just there to collect data and to interpret what the data say. It can't be too specific or too general. If it's too general, then you can't really come to any conclusions. If it's too specific, it might be too specific to generalize to any other kind of circumstance or outcome. It is a prediction that has consequences, and it is valuable even if it is proven false. So this second piece here is kind of hard to think about, but like sometimes it's helpful to know if you have a hypothesis. If it's true, that's interesting, but if it's false, that's also interesting. A lot of things you're going to be doing actually probably are like this, where it's very valuable to know even if your hypothesis is not proven true. Alright, so this would be a really great time to take a break if you are interested in taking a break, and then pop back in and then we'll go for a little bit longer. Alright, so let's get into a quick example of this kind of cycle of science. So if you want to think about this, we can try to think about like the effects of blank on blank. The example that I gave you was earlier was about social media and extroversion. So let's use that. So I want to know the effects of social media on outgoingness. So how outgoing somebody is. Alright, so I think my theory, because I've seen it, is that I think that the people who use social media a lot are also the people who travel and who visit, with friends a lot, because a lot of their pictures and a lot of things they talk about is going to places and seeing other people that they know and hanging out with friends. So I think that being on social media more is going to make you more outgoing as a person. It's going to make you have more friends and things like that. That's my theory, because I've seen people do that. Why do I think that happens? Well, because I think that being exposed more to social media means that you're going to be more likely to be a person who is interested in outgoing things. So my theory is basically that that these things are connected because, and I'm emphasizing the word because social media trains people to become outgoing. Let's say that that's my theory. Okay, cool. So from there, I can have plenty of different research questions. And that's going to lead me to a research design. So my research design is going to be like, I'm going to have two groups. So I'm going to have like group 1 here, and they're not going to have any social media. And then I have this group right here, group 2, and they are going to have lots of social media. So this one group, they're not able to look at TikTok at all. This other group, they have to use TikTok 8 hours a day. And then I'm going to measure, at the end, how many friends do they have? I don't know. And you can decide how we measure what, friends. Do you mean followers on TikTok, or do you mean like actual people, like contacts, in a phone, or what? So that's my research design. That's going to lead us to a hypothesis that we can test, right? Because what we're saying is our hypothesis is that people in this group, the lots of media group and lots of social media group, are going to have more friends. So we would say if someone uses social media frequently, then they will have more friends. And then if you wanted to, then you could say because social media trains people's social skills or something like that, if that is your theory. So this is a testable statement, right? We can take that, we can do some research on it, we can collect the data, and then we can either support this idea or not support it. So let's say that we do this experiment right here, and what we find is that the people in group 2 do report having more friends at the end of this study period than the people in group 1. If that's true, then that supports our theory, which means then we can say that, okay, it looks like social media is training people to be more social and training people to be more social and to be more outgoing. So then we need to be a little bit more specific. Maybe we could say that we think that it's TikTok specifically, that TikTok is training people to become more social. And if that's the case, then we would adjust our theory to say that it's TikTok that's doing this. And then we would do this exact same study where now we have one group that is, because as you can see, that theory is going to kind of change up our question here. Instead of having one group that's no social media and one group that's lots of social media, maybe we have one group that is TikTok and then one group that is Instagram or something like, or Snapchat. And then we measure the same thing, how many friends. And then that's going to, we will get the data, and maybe it supports what we think, or maybe it doesn't. And then either way, we can continue to kind of refine this research process. But let's say that we did this first one here. If someone uses social media frequently, then they will have more friends. We do that, and it turns out that that's not the case. There is no difference between these two groups, the no social media group and the lots of social media group. If that is the case, then we come back up here. And then we have to make a decision. Do we want to revise our experiment, or do we want to revise our theory? Maybe at the end of this we look at it and we're like, oh man, that research method is bad. That experiment looks bad. It doesn't look effective. If that is the case, then maybe you could say like, okay, well, instead of having no social media or lots of social media, maybe we should look at having people either use no social media or use 12 hours of Instagram a day. 12 hours of TikTok a day. That would be refining the research design to try to figure out if there's a problem with your experiment or if there's a problem with your theory. Because one outcome of this may be that we were wrong about our theory. Maybe social media is not training people in their social skills. And if that's the case, then maybe it's something else. Maybe we could say, for example, that maybe it's the case that people who are very outgoing naturally gravitate to social media. So that's some examples of that. So now we're changing gears a little bit, and we're going to be talking about the different kinds of methods of psychology. And this is where I feel like we're going to kind of keep it light and keep it moving pretty quick, because a lot of these ideas we're coming back to later in the semester. So of the goals of science, the first one that I mentioned was describing, and that's whenever you're kind of describing the different kinds of behavior. So if you were to say, like an example of this would be like, how often does your boyfriend say like in a sentence? And you were to count that up, that would be an example of describing behavior. You're not saying why he says like all the time. You're not predicting when he's going to say like, but you're saying he says like 10 times, 10 times an hour, for example. Or if you were monitoring, when does he change the channel after watching television? Or, how long does he browse the Netflix queue before actually deciding on something to watch? Or what websites does he visit? You shouldn't worry about that. That's being nosy, I guess. But the answer to either of these is going to be something more descriptive in nature, where you're talking about when this happens, or what it is that is happening, how often it happens, and things like that. So this can tell us about behaviors, what they are, how often they occur, and all of that. So some of the different ways that you can measure this, the two popular ones are naturalistic observation and laboratory observation. So naturalistic observation is essentially going to look for that behavior in the wild. So an example of this would be like, so let's say that we want to understand how long college students browse their Netflix queue or their HBO, like HBO Max or whatever. How long people browse that before they actually choose something to watch. Because for me, I can take embarrassingly long to do this. So if that's what you want to do, let's say that you want to do this in a natural setting so that people aren't getting biased by... I feel like I'm getting ahead of myself. But people aren't getting biased by having to come into a laboratory or watching it on an unfamiliar TV. You want this to do this from the comfort of your home, so that way it reflects their actual behavior. So that would be a naturalistic observation. You would, invite yourself over to go over to people's houses to see exactly how long they are taking to make a choice for what they want to watch that evening. So what is that behavior like in the wild? We would do this when we were concerned about, we want to make sure that people's behavior are exactly how they are when there are not scientists looking over their shoulder, or when they know they're being observed, because for me, if I know that someone's watching me, if, for example, my spouse, if we're trying to find something together, I'll probably pick something pretty fast because I don't want to just do it on my own. There's been times where I'm eating lunch and I'll try to find something to watch, and I don't want to eat before I choose something to watch, and then it gets cold before I find something to watch. So that's the kind of behavior I want to measure, and so I would want to find that in someone's natural setting. If I wasn't so concerned about the natural setting, then maybe I can invite them to a laboratory where I have a computer set up and I'm allowing them to choose when they are going to find, something to watch. So that would be if I didn't really care all that much about the naturalistic setting of things, if I didn't think that the naturalistic setting was so important to that behavior. The advantages of having kind of observational data like this is that it gives you lots of data, it gives you lots of flexibility, but the problem is that it can sometimes be hard to draw causal predictive explanations. It doesn't give you a whole lot of control in your experiments. Another final descriptive method is called a case study, and we'll talk about these a lot more later this semester. So a case study is a really in-depth interview or study with an individual or with a group of people. And this usually happens for when there's a rare case or a rare behavior. An example here would be HM. Actually, I'll tell you about HM in just a second. I'll give you maybe a more salient example. I know a lot of students are really interested in serial killers. A lot of psych majors gravitate towards that, probably not as much as our CJ majors do, but psychology majors are really interested in like what drives someone to become a serial killer, you know. So you probably know about Ted Bundy or Jeffrey Dahmer or Charles Manson, you know, these people whose names are kind of synonymous with fear and evil and despicable acts of violence and murder. So there are not a lot of those people around, right? You can't name that many of them. Well, some of you probably can, but there's not that many of them that have been around. There's not that many Ted Bundys that have been around, and so it can be helpful for us to spend a lot of time investigating one of these people so that we can try to understand why they became the way they did. So that way we can try to stop or prevent, you know, or save people that from becoming that. So if there's some rare kind of behavior, some like serial killing, or sometimes people will do this with groups of individuals. So like looking at cults, for example, cults would have case study. Because there's not very many of those cults, so we want to know more about them. And actually, the word cult is derogatory. If you're doing that kind of research, people usually call it like a new religious movement, just so you know. But let's talk about HM. HM is the most studied individual in all of psychological history. He is a guy who had his hippocampus removed in a surgery, and after that, he could not create new memories. And so, the disadvantages to case studies are that they take a lot of time. You're sitting down with one person, you're asking them a bunch of questions, maybe you're testing them with a series of measurements and tools and things like that. So it can take a lot of time, it can be very expensive to do, but the advantages of it is that it can give you a lot of data and a lot of really great data. So this is HM. This web link here will give you a little bit more information if you want to know more about HM. I think he's fascinating, but I'm also somebody who studies memory, so of course I find him interesting. But if you're interested in HM, his name was, because he's passed away, was Henry Molaison, and the reason why everyone knows him as HM is because people studied him and published research about him while he was still living, and so they wanted to protect his identity and his privacy, so he just went by HM for all this time. Alright, and then the final thing that I want to mention about descriptive methods are survey methods. So where you are presenting people with self-report surveys. So asking, on a scale of 1 to 5, how helpful do you find this lecture slide? With 1 being not at all helpful, and 5 being very helpful indeed. That is an example of a survey method where I'm asking questions and then just getting data back from self-report. And usually I would do this if I'm like administering the same questions to a large group of people. Like if I were measuring, you know, if I was interested in looking at, do you think that the commuter lot on campus is satisfactory on a scale of 1 to 5? I would want to administer that to a lot of different people, right? And so survey method would probably be the best way of doing that, instead of trying to sit down with every person who might have some feedback on this on campus. That would take forever. Instead, I might just give them a survey that I try to administer online because it's cheap and easy. But the downside to that is you get a lot of data, but the downside is that it can sometimes be hard to generalize and it's not always predictive. So just because someone reports on a survey that they like something doesn't necessarily mean that they actually like it in real life. And we'll talk more about that in a different chapter where we talk specifically about self-report data. I'm going to pause the video for 1 second and I will be right back. Alright, we are back. I thought that I could make it this whole time without some coffee, but I couldn't resist. So in case you're curious, that is a cold brew Dunkin' caramel swirl with oat milk, and it is really, really good. I think I kind of like oat milk. I didn't think that I was going to because it seemed just kind of, I don't know, kind of fancy, and I'm not really a fancy person. Pretty good though. Alright, so let's get back into it. We're talking about predictive methods here. The primary one that I want to talk about here are correlational methods. And there's a really good chance that you've heard a lot about correlational methods already, and we're going to be spending a lot of time talking about correlational methods later this semester. So this is just kind of an introduction to the idea. But correlational methods are the measurement or the relationship that one variable has with another variable. So how these two variables are co-related. That is why it's called correlated. Whether or not these two variables are related in any way, I'm not going to say that they cause one another, because we won't know that from correlation, because as a lot of you know, that correlation is not equal to causation. I know you've heard that phrase before, probably in your Psych 101 class even. We'll talk about it a lot this semester, but it comes up now. So the advantages of a correlational method is that they're very cheap. You can cover really huge data sets doing that. And there are a lot of variables that we can't manipulate ourselves. We have to just kind of let those variables occur and then look for relationships and patterns with them. The disadvantages of this, though, is that it doesn't tell us why a behavior occurs. So let me give an example of what I mean about like some variables we can't manipulate ourselves. So let's say if I was interested in looking at the effects of height on outgoingness. And I think that people who are taller are less shy, and people who are shorter are more shy. So I think those two things are correlated. I think that height is correlated with outgoingness. I can test that, but I have to use a correlational method. I can't use an experiment, and here's why. Can you manipulate height? Can you assign people to a height group randomly? No, you can't say like, hey, Professor Daniel, you're standing at 5'8". How about you be part of this tall group? We want you to be tall. We want you to be 6'6" for a full year, and see if that changes your outgoingness. That's impossible to do without. Well, I guess I could wear stilts or something like that. We can't manipulate height, so that keeps it a correlational measure. In terms of correlations, there are 3 different outcomes that you might find where you have a positive correlation or a positive relationship here. So as one variable increases, the other one does too. In this specific example, we're looking at how much someone expresses gratitude, with over here on the left, we have very little gratitude, and over here on the right, a lot of gratitude. And then we have on the y-axis how long that relationship is, where up here we have 8 years, and here we have 0 years. So as it goes up, the relationship is longer, and as it goes to the right, we have more expressive gratitude. Sorry, I have the hiccups. And so if you look at this pattern, it looks like this pattern generally reflects a trend, what we are going to call a positive correlation. In other words, as we move further on this axis, on the x-axis, as we move further down this way, that we see that these values get higher as we move further down. As we move further to the right. And if we look on the y-axis, whenever we're looking way up here, it looks like the ones that register as you know, this 6 over here and the 7 over here, that these are further to the right than the 2 and the 1. Right? So, and it's not a perfect correlation, right? There's still a lot of variability here, and that's fine. You're going to find that a lot with human behavior. With human behavior, there's always a lot of variability. But this shows what we call a positive correlation, which, for those of you math nerds out there, means that if we were to diagram out a predictive equation, that this would have a positive slope. Don't worry about that for this semester. That'll be next semester in your stats class. The next relationship is called a negative correlation, and this one is a little bit harder to understand because it's kind of counterintuitive, that as one of these variables goes up, the other variable goes down. So here we're looking at how frequently someone multitasks and how good they are at multitasking. And this is actual data, and people don't like to hear this, but the more you multitask, the more that people multitask, the worse they get at multitasking, actually. So those of you that multitask a lot during your everyday life, you might not be so good at multitasking. Please don't hurt me. That's just what the data say. What we're looking at here is higher values represent people who are better at multitasking. Lower values represent people who are not so good at multitasking. Here on the x-axis, 0 means people who don't multitask ever, and over here on the 5, people who multitask a lot in their everyday. And you can see that this has a downward trajectory. That's what gives it a negative slope. So, as someone multitasks more, they get worse at it. If someone doesn't multitask very much at all during their day, then usually when they have to, they seem to be pretty good at it. And then finally, we have zero correlation. Zero correlation means that there's no real relationship between these variables. And so we have for these variables the time of dinner and childhood weight. So time of dinner being when kids eat, with it being early on the left, late on the right, and then how much they weigh during childhood, with up here being they weigh heavier, and down here they weigh less. And you can see there's not really, if you squint your eyes, you can't really see a pattern to this. It's not positive, nor is it negative, so it is not correlated. So we would say this is zero relation or a zero correlation. These two things are not related. So the reason why this is a predictive measure is because essentially, if you know, for example, I'll go with this example right here. Let's say if you know that someone tells you, you know what, I don't multitask very much, then you might be able to predict that they're probably pretty good at multitasking. If someone tells you, oh yeah, I multitask all the time, then you can probably predict that they don't do such a good job on all of their multitasked items. So you can predict data with this even if you can't just explain why those two things are related. Quasi-experimental methods are whenever you can create groups, but you're not able to randomly assign people to those groups. So before I was using height as an example. So you can create groups of people who are tall and short, but you can't randomly assign them. But let's say you get like 100 people, you could take, all right, the 50 tallest folks over here, the 50 shortest folks over here. That is a quasi-experimental method because it looks like an experiment. You have groups, but you are not randomly assigning them to those groups. Another example would be like if you were studying people who were alcoholics versus people who were sober. You can't tell, or you can't ethically tell people, all right, for this group, we want you to get blackout drunk, 3 nights a week. And for those of you in the sober group, we don't want you to drink at all. You can't do that because that would be super unethical, right? Because somebody's gonna get hurt in that alcoholic group. So the disadvantage here, the advantage here is that it's getting closer to becoming an experiment, so it can tell you a lot about different kinds of group dynamics. It's very, you can still learn a lot from quasi-experimental methods, but it still doesn't quite tell you with certainty why this thing happens, why these variables might be related. And then finally, we have explanatory methods, and explanatory methods are true experiments. So this is where you have one variable that is manipulated by a researcher. So for example, we were talking about, the example of like, if I get tired, then I get stressed. We can turn that into an experiment where I say, all right, I want this group, everybody in this group, I want you to sleep 3 hours tonight. Everybody in this group, I want you to sleep 7 hours tonight. In that case, I have manipulated a variable. I have manipulated how much sleep someone gets or how tired they're going to be in the morning. And that is an experiment because I can randomly do it. I can randomly assign people. I can close my eyes and put them in these different boxes. Now, the tricky thing, the difference between independent and dependent variables. An independent variable is that variable that you, the researcher, have control over, what you can manipulate. So in that example, tiredness or sleep, that is the variable that we are manipulating. We are assigning people to those groups, which means that we are manipulating that variable. We're saying that these people get little sleep, these people get a lot of sleep. And And this is usually going to be the thing that you're interested in. So if you think about things like, I want to know the effects of coffee on studying, then you would say, all right, what you're interested in, your independent variable, is going to be the effects of coffee. That is your independent variable. Or, if I can use a similar example, if I want to say, I want to know the effects of good study habits on my GPA. In that case, the good study habits are now the independent study, and the GPA is the dependent variable. So the dependent variable is what you're measuring as a result. It's kind of like your outcome variable. It's what you're studying to see whether or not there are effects. So usually these are going to be the result of you manipulating that independent variable. So if we're thinking about the effects of tiredness on stress, that would be, stress would be the dependent variable, where I have made this group tired, and as a result, they are now more stressed. In this case, stress is the dependent variable. It is reacting to the independent variable. We're going to talk more about those in later slides. Experiments are so great because they are the only way for us to truly understand causal mechanisms of behavior. Now, what the heck does causal mean? And just to be careful, it doesn't mean this. Casual, casual means laid back. This is different. You can see that they're spelled different. They're different words. The reason why I bring that up is because I think the first time I took research methods in college, or the only time I took research methods in college, I may not have understood that. I may have made it the entire semester thinking that these two words were spelled the same and pronouncing them the same, which is incorrect. So just a fair warning for those of you out there that are a little bit like me. So the experiments tell us why something happens, and that's because it shows us this causal mechanism that when people are tired, it causes them to be stressed. When people have caffeine, it causes them to stay up late and study. When people use good study habits, it causes them to have a higher GPA. Usually, experiments are going to have a control group or an experimental group, or they have a control condition and an experimental condition. And so that's kind of like the big feature of explanatory methods. They are the gold standard. If you want to use an experiment. They're ideal, usually, but they're not always possible. There's lots of ways in which they may not be possible. A lot of times, because you have to control so many different factors, they come across as not very realistic. They come across as very contrived and not reflective of the real world. And these are all things that you as a scientist should be thinking about and should be worried about. Does your experiment reflect natural, real behavior, or is it only behavior that exists in the laboratory? All right, so if that stuff felt a little discombobulating or like we were speeding through things, that's because we were speeding through things. Those ideas, correlational design, quasi-experiments, experimental designs, observational designs, they are all going to get their own chapter this semester. So we're going to be unpacking a lot of these things, talking more about when is and when is not appropriate to use them. So if you're still feeling a little bit like you're underprepared, that's okay, because we're going to be getting into it. So as some examples here, what method would you want to use if you wanted to know if you want to know if morning commuters do a better job parking than afternoon commuters? For me, well, actually, what I would do is I'm going to put all these up, these four, and I want you to think about them for a second, and then I will tell you what I would say, and I think this would be good practice. So pause this for a second, jot down your four answers. What kind of method that we talked about today would you want to use, and then we'll kind of review them together. I'm waiting for you to pause it. You didn't actually pause it. I know these things. All right, let's go ahead and do it. So you want to know if morning commuters do a better job parking than afternoon commuters. For me, I think I would actually be interested in doing a naturalistic observation of this. The reason for that is because I'm worried that if these commuters know they're being studied, if they know that they're being, put in a study, or that there's going to be somebody watching them and their driving, parking skills, they're going to change their behavior. They're going to be on their very best behavior. They're going to try to park really well. And I want to just look at how they naturally do. So I would say naturalistic observation is going to be the best for this one. But you could easily imagine how you could take, like, you could assign people to being a morning commuter versus an afternoon commuter. It'd be very inconvenient for that person and their family. If you said, all right, for this study, for the next 9 weeks, you have to come in at 7:30 a.m. and you have to come in at 2:30 p.m. So that's why I'm choosing naturalistic observation. For the next one, you want to know if smoking rates decrease mental illness rates by state. In this case, I'm going to say probably the ideal thing to do here is going to be correlation. Why correlation and not something else? The reason why is because ordering somebody to smoke would be unethical, right? We know that smoking has deleterious effects to health, and so we don't want to force someone to be in a smoking group, nor do we want to force someone to be in a mental illness group either. We can't give people mental illness and see if that affects their smoking rates. So the best choice here would be correlation, just looking at whether or not these two things are related. And in fact, they are. That smoking rates, the higher the smoking rate in the state, the less mental illness there is reported by that state's government. If you want to talk about why that is, just let me know. If you want to know how the Westfield president spends their day, how would you do that? Honestly, I'm going to go with self-report or survey methods here. I could do that. Or actually, nope, actually, that's not the best. The best is still probably going to be a descriptive method, but it's going to be a case study. Why is it a case study? Because I'm looking at one specific person. So I can sit down with the president and I can ask them, like how their day was, what they do, what do they eat for breakfast, and things like that. And that would be an efficient way of doing that. And then finally, you want to know if sleep and stress are related. On this one, I would go with an experiment. I would go with the regular, good old-fashioned experiment where I am putting people in a no-sleep group and then people in a lots of sleep group, and then seeing if that changes their stress. This final thing here, I was thinking that this would be helpful, is a callback to the very first video of this chapter that I was telling you about, the confirmation bias. So this is why I want you to think about exactly how can your hypothesis be falsified. Because we talked about how, like, your hypothesis needs to be falsified. You need to be able to test it and determine it's either supported or not supported. So the way to do that is not always super clear and easy, and here's an example of why that is. So remember that we're not trying to confirm what we think about the world. We're trying to rule out all the other possibilities. We're trying to rule out the things that are impossible or the things that are not supported by the data. So let's say that we want to determine this hypothesis, if it is accurate or not accurate. If a person is drinking alcohol, then that person is 21 years or over. So which of these would you flip over to determine, and I should say this card, each of these cards is going to tell you how old someone is and if they are drinking anything. So which of these cards would you flip over to test just this statement, and only this statement? I don't want you flipping over any cards that aren't relevant here, okay? So be very careful. You'll want to pause this and think about it. This is one of those things where I guarantee you sitting down and thinking about this will be helpful in understanding the point that I'm trying to make here. So pause this video for just a little bit. You didn't pause it last time I asked you to, except for maybe a couple of you, but try it here. So which of these four cards would you flip over? All of them? None of them? A couple of them? Which ones would you flip over? Okay, so I let you pause it. I gave you time to think about it. So let's think about each of these. Which of these would we want to flip over? What about 17 years old? If we flip this over and someone is drinking alcohol, does that affect this statement? Does it? Looks like it might. We would want. Sorry, I didn't realize. Never mind. I thought it got rid of that statement. We would want to definitely flip over this one. Why? Because if we flip over this 17-year-old one and it says that they're drinking wine or beer or whatever, then that disproves our rule here that basically they were drinking alcohol and they were not 21 years or over. So this would be one of the ones that we would absolutely want to flip over. This next one, we would also want to flip over. This one, I bet most of you probably got this one, right? Because if a person is drinking alcohol, okay, they are drinking wine. That is the first piece here. Then if we flip this over, if that person is 21 years or over, then that's cool. But if it's less than that, then that's a problem. So that would be an issue. Okay, but how about these others? I usually, whenever I give examples like this in a physical class, in an in-person class, people will be like, wait a second, I chose these, how come these are not correct answers? Here's why. So, 23 years and older, if you flip this over, and there is, let's say, someone drinking alcohol, what does that mean here? Okay, it just reconfirms this. That's fine. But what if we flip this over and they're drinking Coke? Does that disprove this? It actually doesn't, right? What we're saying is that if a person is drinking alcohol, then that person is 21 years or over. So, if they're not drinking alcohol if I flip this over, then it has no bearing whatsoever on this hypothesis. It's totally irrelevant. Even though it feels like it might be relevant, it's actually not relevant. What about this one over here? Drinking a bottle of Coke. So, if this person's drinking a bottle of Coke, if I flip this over and they're 37, does that disprove this hypothesis? It doesn't either, right? Because I don't specify that if a person is drinking alcohol and the person is 21 years or over, I don't specify that in order for someone to be drinking alcohol, if someone is over 21, then they are drinking alcohol. If that were the case, then flipping these two over would be helpful. But that is not what the question is. That's not what the hypothesis is, right? So this is just to say that whenever you are studying this stuff, when you're trying to study a hypothesis, it's always super valuable to think about what it would take to falsify, what it would take to disprove that hypothesis, because that is what you want to test. You don't want to test the things that confirm that, right? Because flipping over these two don't really tell you anything about this hypothesis. They don't prove it or disprove it. But going against the things that could disprove it, they do tell you about that hypothesis. And that's all that we have here. I think that's basically an hour. So thank you so much for tuning in. And because you made it to the end, I'm going to show you my other dog. So give me one quick second here. Come on. I want to show you off. As you can tell, he's been sleeping. But this is my other dog, Fozzie. You met Hopper at the end of video number 1. This is Fozzie. He's the best. I'm not gonna say he's my favorite because I shouldn't say that I have favorites. The other two dogs that I have in my house are they're more close with my wife, and this one he's more close with me. That's why you'll almost always see him laying in his bed over there while I'm recording his videos, because he's waiting for me to be done so that he can either cuddle or play. All right, thank y'all so much for tuning in. I will see you later. Bye, everybody.